Hello, everyone. My name is Nicholas Elsesser, and today I'm going to be talking about my final project, which was a securities exchange. All right, so what is the purpose of an exchange? An exchange exists to facilitate transactions between market participants. So as you can see on the diagram, we have Joe, who is trying to buy 100 shares of Apple for at most $50 per share. And then we have Bob, who is trying to sell $50 of Apple for at least $40 per share. And so both of these market participants will submit their orders to an exchange, and the exchange will match their orders. And as you can see, we'll have Bob sell 50 shares of Apple to Joe for $50. So both participants are happy in this case. And so we want to match orders based on their price time order. So the most desirable price or the first order with the most desirable price will get matched first. And then we also want to maintain a high throughput under load. So we want our exchange to run quickly for thousands of market participants and millions of orders being submitted. And so these are the components that I use to build the project. So I use Kubernetes for the deployment and scaling of ancillary services. So these are things like the price and account management. They're not the direct order matching services. And then I used cloud VMs for the order matching. So each order book has its own dedicated VM. So that way they don't interfere with each other. Then I use Google PubSub for messaging because of its good integration with the rest of the Google services. And then I use MySQL databases and Google storage buckets for storage and data logging. And then I use the Flask REST server for the API interface. And so here you can see the architectural diagram. You can see that the REST clients send requests to the server, and the server is inside a Kubernetes cluster. And the orders are then sent to the corresponding order book on a pub subtopic, where they are first put into the matching engine. And then as orders are matched, they get outputted onto an events topic that is dedicated to that order book. And then the raw events are logged to a bucket, a storage bucket. And then they're also passed into a data flow stream, which then splits the events into the shared price updates and accounts updates topics. So those topics are shared between all the order books. And then those events go into the price update and account update services, which then interact with the SQL database to update the price and then user accounts. So updating which orders are open, closed, filled, and then the price updates aggregates the price per minute. So you get a little candlestick of the price per minute stored in the database. And then the REST clients can request data from that database through the REST server. And so for debugging, each component was individually tested to work. And then all the order book updates are logged into the storage bucket. So if there's anything, you can go back through all the event updates and debug what was going on. And then all the services log each of their transactions that go through them. So the REST service logs transactions. The price and account update services log every single update they make. And so some things that I learned is that the database transactions are slow. So every single update has its own database transaction, which is unnecessary. The services should aggregate the transactions in memory, and then every once in a while commit them to MySQL to kind of reduce the load on the database. And then these services also become overwhelmed quickly. And so this is something I didn't explore, but we can auto scale the number of service pods in the Kubernetes cluster based on the number of unacknowledged messages in the pub subtopics. And then also they're implemented in Python, which is slow, so they could be implemented in a faster language.
Okay, and here is a quick demonstration of the project working. So I have a script that generates random trades. So it has 50 different traders or 50 different threads running, and they each generate 10 trades per second. Then they also occasionally will clear out any unfilled trades that are still open in the exchange. So I'll get those guys running. And you can see here they're submitting orders. And occasionally, if we pause, you can see they're canceling any open orders that they have. And then I have another script that will pull the prices and show it as a candlestick plot. So you can see here, this is the Apple price or the price of the asset. And it's a little noisy because the trades are just being generated randomly. but I can run it again and you can see that the candlesticks will update as new trades come in. So you can see we stepped forward in time there and got a new candle. And so I can go again and we'll get another candle. Yeah, we got a couple there. So
And that's my project. Thank you very much.